I was looking for a way to reincorporate this 6J1 preamp into an amplifier, because I figured, hey, what the heck, we'll give it another shot. You can see I removed the whole power supply, and I decided, since I had an extra Leslie 825 amp, that I would try and incorporate that preamp into this amp. So this is pretty much the whole amp section with the addition of these two transistors. And this is the brute force Leslie power supply. However, I ran into a problem, and that is the power supply ripple that was coming out of this at 120 volts. So the question I had is, how did Leslie get rid of that much noise? So the problem with any power supply ripple is this. Here you have the ripple coming in on the VCC side of the transistor. So that ripple is going to go down through this resistor, and it's going to mix with the incoming audio signal. So say we have 1,000 hertz signal coming in here. This is going to mix with this inside that transistor, and it's going to come out like this with undesired noise. So that's why, you know, you have so many problems with ripple and noise and 120 hertz noise in an amplifier. If you have a full wave bridge rectifier, which most are, so you got 60 cycles coming in, and let's say this is just a grounded, a simple double-sided. This is going to come in and it's going to be filtered by a cap right there. But what you get, you got 60 cycles coming in, and the positive cycle of both halves of it is being rectified. So you get a doubling, you get 120 hertz noise. And that's undesirable, so most supplies use some filtration device, and this device is really unique in that the filtration is done in the final stage of the amplifier. So right now you're looking at the Leslie's 42 volt supply. The positive is on channel 1 and the negative is on channel 2. And both of them are basically somewhere around 40 some volts. But we're looking at the AC ripple on both of them. And what's interesting is you can see that the AC ripple is 180 degrees out of phase with each other. So when I tried hooking up one side of the supply, there was no way I could get rid of this noise without some elaborate means. So then I started looking at the schematic. We look at the schematic and we have plus 42 coming in up here across Q13, and we have negative 42 coming in across this resistor. And when we look at the transistor itself, we have that same noise that you saw in the prior section right here and right here. But what's interesting is, since those signals are 180 degrees out of phase, they cancel at this point. Quite the unique design, and no filtering required, because the output transistors do all the work, and then that goes straight to the speaker. So at this point, you have two signals that come in 180 degrees out of phase and they cancel. And that's how Leslie got rid of their power supply noise. But it creates a problem for using that 6J1, which I have an answer to, and I will do another video on the amp that I make. I just wanted to make a head unit out of this because I really like this amp. It basically rocked the house, and I had an extra one. Didn't know what to do with it, so I decided to play with it. So here we have our amp hooked up. We'll power it up. And the speaker's hooked up, but you notice you can't hear anything because there's nothing going in at this point. But if we look at the positive 42 volts there, we can see the ripple right on the output transistor. And if we go to the emitter of the other transistor, we can see the ripple there, and it's smaller because of this resistor. It comes in across this resistor, so it's full force on one side. It's attenuated slightly on the other, so that's what you see here. There's also the same 0.3 resistor on this transistor on the other side of it. So when they get to the center of it, which is the output of the amp, which is right here on the collector, you get no noise. Completely canceled out, even though it's across those transistors.